Welcome back to Code Ryan. Today I am very thankful to be joined by Connor Ardman here. And today we're going to kind of dive into what is good code, what are some tips for writing better code, what are some signs of poor code or some different kind of code smells, so to speak. And then I definitely need to ask Connor what he thinks about kind of latest things coming out in GPT-4 and whether we are all going to have our jobs taken by AI. So first off, thanks for coming on today, Connor.
Yeah, for sure. Thanks for having me.
And for people that might not be as familiar with you, could you just give like a brief background on some of like your history, how you got into coding and kind of what you've done throughout your career?
Yeah, for sure. So I guess you could say I sort of started coding as a kid, sort of like being interested in the idea of like trying to make a video game or an iPhone app or whatever. And then I went to the University of Washington. So that's where I would say I actually learned how to code. Majored in informatics there, which is sort of like a mixture between computer science and some like design and project management and things like that. So yeah, did that. I guess fell in love with coding, especially the front end. Then I went to Facebook. I worked at Facebook for a little bit over a year. Mostly did front end work there. And then I left Facebook I guess it's been like almost 18 months now. I think September of 2021. So I left Facebook after a little bit over a year to join Algo Expert, which, if you're not familiar, is like the coding interview prep platform, and created the front end expert course over there. So essentially we help people learn front end development and prepare for front end interviews. And yeah, that's mostly what I do now. And then I have a YouTube channel and TikTok and all that, where I just make content about front end development, software engineering, the industry, I guess. And more recently, ChatGPT videos.
Awesome. And I've also taken Connor's course here over on Algo Expert, and definitely a really awesome course. Not only for like, because I took it like when I already had a job and stuff, like I just wanted to kind of like review the fundamentals and kind of like I was intellectually curious if I could pass like the test, and I didn't pass them all on my first shot and stuff. So I definitely recommend, even if you're not like necessarily looking for a job or doing interview prep, like it is a good kind of review. Just kind of go back over the fundamentals. You guys got some good crash courses over there, I think, on HTML, CSS, and JavaScript, and then also some nice kind of ways to test yourself and stuff like that. So definitely recommend that. But kind of transitioning here into the topics today. So you also have some videos on your YouTube channel that kind of discusses kind of good code versus bad code. And I think people listening to this have probably like heard someone say, oh, that's bad code, or, oh, this is really good code right here. But like, how can someone even qualify whether code is actually good or bad?
Yeah. So I think at the most basic level, it has to be correct, right? Like if your code doesn't do what it's supposed to do, it's, I think, objectively at that point, bad code. But then there's sort of the more nuanced part of it that's like, is this code going to be easy for your team to maintain? So can this code be maintained over a long period of time, even once you leave the team or the company or whatever? And then also, is that code going to be easy to test? So not only is it correct, but can you easily write tests to prove its correctness? And therefore, when you're maintaining it, make sure it stays correct. So make sure when somebody makes a change a year down the line and they don't remember what the code was for to begin with, that they aren't breaking something that they don't even know that code is doing. And sort of related to that is like making sure that code's not overly coupled with other code. So if you change some piece of code and it has some downstream effect that nothing in the code implies it's going to do, then that to me would be bad code, because eventually someone's going to need to change that code. And when they do, it's potentially going to break something they didn't even know depended on that code. And then obviously performance matters to some extent too. I made a TikTok about this recently that some people did not like, where essentially the premise was just that performance is important, but I think a lot of times it's overemphasized. Like I think a lot of us come from academia where it's super important, right? Like it's something that we are literally tested on when we take classes and algorithms and things like that. And it is important in a lot of scenarios, but there's also a lot of scenarios where it's not as important, or it's not as important at like a micro scale. Like performance is super important at a macro scale, right? Like making sure that we don't have extra trips to the server, extra trips to the database, things like that. But then on like a micro scale, you could say you could optimize performance by removing all of the functions from your code and putting it all together. And that code, while it might be technically slightly more performant, it's going to hurt all the other areas of readability and maintainability and all that. So sort of a lot of trade-offs with performance and all of the other ones. And that sort of depends on what exactly it is you're writing. Like if you're making a website, then you probably are more concerned about maintainability and uptime and all of that, and less concerned about that super micro optimizations. But obviously performance is another factor, I'd say, in the what is good code. Like if your code could be replaced by other code that doesn't harm the other factors and is more performant, then I would say your code is maybe not bad code, but it's not objectively the best code either.
Mm-hmm. Gotcha. So really good code would be code that is correct, code that is potentially has like a decent amount of readability, which is somewhat subjective, but I think more or less, I think if you showed 10 coders different pieces of code, they could probably come to terms on what looks a little bit more readable or not. And then code that is a bit more testable, maintainable, and then performant. And you kind of started diving into optimizations and maybe micro versus macro optimizations there. And I think we'll get to that here in just a little bit, because I totally agree that with that, I think it's just important to focus on like what's going to give you the biggest bang for your buck. You know, is making this function an inline function versus a function definition really going to matter that much at the end of the day? Probably not, but is making 10 network requests versus one going to make a big difference? Yeah, probably. So we'll probably dive into that a little bit deeper here, but kind of with that layout of what is good versus bad code, how does someone actually go about writing better code? Like what are some kind of general tips that someone can kind of keep in their head to make sure that they are writing a little bit better code?
Yeah. So, and what I touched on for a minute was sort of the idea of avoiding coupling. Like I remember when I was in school, something they taught us was this. So you've probably heard of like the DRY principle of don't repeat yourself. And it was taught to, and maybe this was just me misunderstanding the way it was taught. It probably was me misunderstanding what they were trying to teach me. But the way I interpreted it as a college student was, if I have two lines of code that are the same, move them into a helper function. And that sort of principle oftentimes is good, but really the idea of the DRY principle, what it was meant to be when it was originally written, was don't repeat yourself in terms of knowledge. So the idea that like the same business logic should only exist in one place in the code base, whereas the same code that just happens to coincidentally be the same potentially can exist in different places. But I'd say from a high level, making sure that you're not repeating the same business logic in multiple places is a really good place to start as far as keeping code readable, maintainable, whatnot. You want to just maintain consistency. Like I think there's oftentimes these debates about specific practices in code and which one's better than the other. And oftentimes it just doesn't matter. Like the canonical example is tabs versus spaces, right? It does not matter. But what does matter is being consistent. And if you have a code base where half of the files have 2 space tabs and half of them have 3 spaces or 4 spaces, it just becomes a little bit of a mess. And then once you add 20 more of those decisions that everybody on the team independently made, you end up with a huge mess of inconsistency that just makes code sort of jumbled and hard to follow. And I think a really good thing is just following a style guide. One thing that I found helpful when I was first learning was going to two of the best ones, I'd say, is the Google style guide and the Airbnb one. Both of them are open source. You can look at them online, and they are the guides that the companies use internally. And they aren't necessarily things that are objectively the best decisions, but they are just decisions they have made. Like, this is the way we're going to write this code. This is the way we're going to write this code. And because they have that, they get super good consistency, which helps keep their code super readable and all of that. And of course, those are things that when you actually work at the companies, they probably are automating, so you don't even have to think about it. but just trying to follow things like that, I think, are really important. And also trying to avoid prematurely optimizing anything. So on that optimization point, think about the actual product first and think about the code second. So like code isn't the product is sort of a phrase we hear a lot. And oftentimes if you think of code as the product, you think about all these ways to start optimizing things super early, and you end up with this mess of a code base because you went so far deep in this like super optimized code. Whereas instead, if you think about what is the product I'm building and sort of start from there, I think it tends to just end up better.
Absolutely. And to your point on consistency, one thing I thought about there is like, kind of like you alluded to, a lot of companies will use kind of automatic formatting. So something like a tool like Prettier or something like that, that you can kind of have a definition file of kind of different ways of doing things throughout your program. And then on save, it kind of formats those things alongside your style guide kind of right within that. So I think that can definitely be useful. And then one thing that you also mentioned in your video was making sure to plan ahead of time. And this one definitely really resonated with me, as my default is just like to start writing code and to just dive into things. And then by the time I spent 2 hours trying to solve the problem, I realized that I'm going about it the wrong way and just not doing things very well. So could you maybe hit on this point a little bit on why kind of maybe thinking about the problem a little bit beforehand is an important thing to do?
Yeah, for sure. So, and I do that too. Like I have the same tendency of I am coder, therefore I write code. But yeah, if you spend some time and actually think about what exactly is it that I'm trying to do in sort of that line of what is the product I'm building and what are the core components of that product, and break it down into pieces, it makes, for one, the actual coding process much more approachable once you've broken it down into these are the different components I need, these are different modules I need, whatever it might be. Once you've broken that down a lot, it becomes much easier to write the code, but then also you avoid that process of writing some code, realizing the code you wrote isn't the best way to do it. So you delete some of that code and then you re-implement part of it in some other way. And then you end up with this code where you implemented it multiple times and maybe you redid some parts, not the other. And then your code becomes inconsistent even with itself. And that's something I still struggle with a lot too. Like I uploaded a video literally this morning where I built a Tetris clone in React. And I sort of did the same thing. I just sort of started coding. And I don't actually show this in the video, so maybe I should have. But the original implementation I had probably 20 different use state calls for different pieces of state for like the Tetris game. And after I spent like an hour and a half or so probably writing that code, and like it was done, it was working, I realized that the code was just super hard to read, and that there was a much cleaner way to organize that state. And had I thought about ahead of time, okay, what are the different key components to the state of a Tetris game, then I would have ended up with far less state. And eventually I did just redo the entire thing. And it wasted a bunch of time because I didn't follow that principle.
One thing my engineering manager has mentioned to me before, like programmers will spend 8 hours coding just to prevent like 1 hour of planning. And it's definitely true, to where a lot of people just like to dive into it rather than thinking about it ahead of time. And it's hard not to. Like I still catch myself working on just my daily tasks. Like, hey, stop and think about this for like a half hour before diving into it. It always goes much better. So I definitely think that's a good tip. And maybe similar or along kind of the same lines, you've kind of mentioned good commenting practices. And I definitely think that this is one thing that people have differing opinions on, to where some people are like, you should always be commenting your code. It makes things much more readable. And then there's other people that are kind of on the other side, that you should write your code in a way that you don't need to comment. It should just be self-documenting. So where do you kind of fall on this commenting debate here?
Yeah. Before I give the hot take, I'll give the better take, that just do whatever is already happening in your code base. I think consistency is more important than anything else. But I was always somebody who's like, everything should be commented, right? Like you should explain everything. And that was the way I wrote code for a long time. And then the first few pull requests I put up at Facebook, all of them had feedback of delete these comments. And when I thought about it, it sort of made sense. Like sort of the self-documenting code thing you said, if your code is well written and you assume the audience of your code, so the people actually reading that code are sufficiently knowledgeable software engineers, then they should not need an explanation of what your code does right above the code. It's just sort of wasting a lot of space and sort of adding a bunch of mess to your code that isn't doing much. I think there's a time and a place for comments, but my general thought process now is that if you're writing a comment, fundamentally that means that there's something in your code that was hard to understand, because that's the only time a comment actually makes sense, in my opinion. If you're writing a comment just to tell somebody what the code does and it's obvious what the code does, the comment's just redundant with the code. So then if writing a comment means that something is fundamentally hard to read, then there's a high probability that that just isn't very good code, and there's probably just a better way to do it. So to me, when I go to write a comment, I use that as sort of a warning sign that potentially I wrote code in a bad way and should think about how I wrote that code. And there are times when you just need the comment, right? Like there's times when that code is how it needs to be, and you need to write a comment to tell somebody this is why this is like this, don't mess it up. But more often than not, that comment can either be replaced with better variable names, test cases that would fail if those things were changed, all these other good code practices that I think oftentimes mean that the comments aren't necessary, but there are use cases where they matter. And then also things like adding to-do comments in code of things to come back to I think are important.
Yeah, I land in the very same exact spot. I think for me, just like you said, when I'll be writing out a comment, and then as I'm writing it, it's just kind of like, all right, now I need to second guess myself. Did I really write like the most thoughtful code here to actually make it kind of a little more self-documenting, or did I just kind of use some janky logic to try to get to my result? And usually it's the latter there. So I think that is definitely important. And I think that, you know, it's not like an all or nothing thing. Like sometimes comments are helpful, and sometimes explaining your rationale for a piece of logic can be beneficial. But I would also say on the flip side, make sure your comments remain up to date in your code base, because it's very easy for you to have stale comments in your code base, and then it ends up being like, why is this comment here? It doesn't even relate to this code. And then things just get messy really quick. So I would say definitely you could use them here and there, but maybe sparingly. And then also it might be an indication that you might not have written the most clear code if you are finding yourself needing to comment quite a bit. So really like that one there. And then also you mentioned kind of keeping things to a single responsibility and writing some more modular code. So could you maybe speak to what it kind of means to write code that has more of a single responsibility and making it more modular?
The idea is very simple, just like the name single responsibility suggests. Of quite literally a function should have one purpose, a class should have one primary purpose. That doesn't mean a class can't have multiple methods and whatnot, but it should represent one thing. A function should represent one behavior, action, or whatever, one piece of functionality. And once functions start having multiple effects, I think that's just usually a time to start breaking that function down into smaller functions for a lot of reasons. For one, it makes your code harder to test. If you have a function that does two different things that might be related, right? Like they're in the same function for a reason. You wrote it that way for some reason. But once they start doing two different things, it's much harder to unit test that function, because now your unit test has to test for two different things. And that also sort of becomes less maintainable, because down the line, somebody's going to need to edit that function. And when there's sort of some secondary action that function is also controlling, it just makes that function a little bit harder to actually edit. So I think just in general, keeping all functions to one main responsibility, all classes to one responsibility, and really all like chunks of code doing a single thing is just usually, I won't say always, but usually a good principle. It just keeps code easy to test, easy to maintain, and easy to follow.
Goes back to keeping code in what qualifies good code. Like it keeps it a little bit more readable, more testable, maintainable over time. And it looks like maybe you had one other thing to add there.
Oh yeah, I was gonna say, as an example, if you've ever tried to look at like some open source code or code or code base of a company you work at or whatever, that might not be something you implemented. And when you open a file and it has like 500 lines of code, or you look at some function and it's 50 lines long, it immediately becomes one of those things of like, I'm not going to understand this. There's no way I'm going to figure out what this does. And maybe if there's a bunch of comments, you might be able to start figuring it out. But if that code was instead in a bunch of smaller functions, each with good names, it's usually much easier to just look at those function names, look at the order that the functions are called in, and very quickly be able to tell what that code's doing.
Absolutely. Because most of the time when you're like trying to figure something out, you don't necessarily need like everything. You just need like in this one function, I just have to see how this is called, and then I'll be able to kind of solve the issue I'm running into. And when it's much more modular and you can just go to that function and it's 10 lines, you can figure that out. But when it's 500, like you said, it's very daunting and is going to take much more time. And, you know, I'll definitely admit at our code base, we definitely do have some super long functions that are like 300 or 400 lines. And I think to some extent that is pretty common in most people's code bases. But do your best with this. It doesn't necessarily mean you can never have something ever do multiple things. But in general, trying to keep things to less responsibilities is probably the better approach there. So I think that gives a good rundown of some tips to write kind of better code. So now I think a good place for us to transition into is, what are some things that people can look for, or some maybe like red flags that can go off in someone's head for bad code? And these are also commonly called code smells. So what kind of comes to your mind there?
Yeah, I think there were a few I mentioned in that video, but some of the ones that come to mind would be, for one, bad variable names. So like if you have a variable name that's not with functions or just variables, that's not immediately clear what that thing does. One, it just might just mean your code's just hard to read and you should fix your variable name, but it also could potentially mean that what that thing does is unclear, right? Like if you have some variable that is potentially doing two different things and is sort of being reused in a bad way, it's going to have a bad variable name. So keeping variable names good and clean. Another big one is magic values. The example I've seen given a lot that I think is very obvious is if you have a price and you see it multiplied by some other number, and it's just some hard-coded in number. You don't know what that is. Is that sales tax? Is it a local sales tax? Is it federal sales tax? Is that a discount code? Is that a bundle pricing of some sort? Right? Like there's a bunch of things that could be. And by just hard coding in some number, it becomes unclear what exactly that is. But if instead it is a variable or a constant called sales tax or called local sales tax or whatever it might be, then it becomes much easier to read. So just in general, if you have basically any number in your code other than 0 and 1, I would say probably needs to be replaced with a constant. Some other ones I would think about would be like like I said, super long functions, but also functions that take in a bunch of parameters. Because like if your function has 10 different parameters it's taking in, then it's probably doing more things than it should be doing. Like there's probably something overcomplicated there. Or on the other hand, it's potentially a issue of your actual variables or parameters that it's taking in are poorly defined, right? Like if you see a function that takes in name, age, I don't know, more things about a person, email address, whatever, maybe that needs to be a person object, right? Like maybe we don't need to pass in every single component to a person all at once or all as separate pieces. So those are some of the biggest ones I can think of. There's tons of them. Like there's lists online of like code smells that'll have like hundreds of them. Like I think there's people who've literally written books on the concept of code smells. But I think the biggest one by far for me is naming. Like if you see something that has a bad name, that almost always means that they were, or like if you're struggling to come up with a name for something you did, then that's to me a really bad sign about that code I just wrote.
And I would say the naming one also comes back to consistency. It's where I know we've had it before to where we will use some value on our program with this name in one place of our code, and we'll reuse that same name, but it will be like for a different type of value. And those kind of inconsistencies and calling things the same thing or using the same variable for two different things, that can definitely make things tricky as well. And I like what you mentioned about using multiple parameters, because I know like in React code specifically, sometimes you'll have a component that has like 15 different props, and almost always that's a sign that something could be structured a little bit differently there and improved. As at the end of the day, when you're using those props, it's kind of just like passing arguments to a function. So yeah, I definitely think those are all good. But before I let you go here, I have to get your overall thoughts on GPT-4 AI.
Yeah.
Should we be worried? I'm genuinely a little nervous, but I can't tell if I'm nervous if it's because like I know some changes are coming or because like I'm not going to have a job next year. What do you think?
Right. Yeah. It is crazy just like how fast it's progressed. I made a short the other day where I played a chess game against GPT-4, which like at its surface isn't that big of a deal, right? Like there's tons of AI that plays chess and is far better at it than GPT. Mm-hmm. But then when you think about the fact that that's an AI that nobody wrote code with the rules of chess, like it just sort of figured out how to play chess. So my overall thought is just that it's sort of one of those things that you can't plan for the unknown. Like my general approach is like, I don't personally think we are anywhere near AI actually replacing software engineering jobs. Like I'm sure there will be a point where it comes eventually, but in the short term, at most, all I could see is it sort of becoming another tool we use, similar to how we use Stack Overflow or anything else. And I think that's for a few reasons. For one, I just don't think it's nearly as close to that technically as people like to think it is. Like GPT is pretty good at coding things in a vacuum. But once you give it a code base of millions of lines of code, I would imagine it would struggle a little bit more. And even if it didn't, there's so many other issues with using the AI generated code, from so literally legal issues of like who even owns this code. Like, do you have IP rights on it? And like, I know nothing about law, but I've heard people mention that as a concern. And then there's also the concern of mistakes, right? Like at this point, it's able to write code far faster than we can, but it's also far more mistake prone than we are. And it takes one major mistake in code to completely ruin a company. And when you think about all of the biggest tech companies, the Googles and Facebooks of the world, that's just not a risk worth taking when you're profiting billions of dollars a year. Like yes, Google software engineers are a big expense to the company of Google, but I can't imagine a world anytime soon where Google would make such a radical change to replace those people that have generated them tens of billions of dollars year over year for the last decade. Like that just seems like way too big of a financial risk for any company to take anytime soon. So to me, we have a pretty long time before we get there. But obviously I can't predict the future either. I do think it's super cool. I've been using it more and more. Like the first time I made a video on GPT, it was before 4 had come out. It was like a couple of days after the first version of GPT came out, or at least publicly, and or ChatGPT came out. And I sort of mentioned it being cool, but not something I think I'd be using much. And now I actually do find myself using it a decent amount, but I use it for things like writing a helper function, right? Like things that are monotonous and it can do quickly. But I don't think there's any world anytime soon where I'd be using it to build an entire feature, but maybe that's something I'll be wrong about.
Yeah. I would say, first off, if anybody says they know, they don't know. Like I feel like we're on that exponential growth curve of AI in which we're just going to have to kind of see how things shake out. But I would say I mostly agree with everything you said. Like, it seems to be really good at like starting from scratch on something or to build these helper functions and stuff like that. But like once it needs to like have the entire context of an entire code base and an entire architecture of an application, like if people have like Kubernetes set up and different stacks and containers and stuff like that, like once things get complex, I think that you're going to need some human interaction with it. Now, I definitely think that it's going to be something that probably augments software engineers and makes them more productive, which if a software engineer is now, 5 times more productive, you could argue that you don't need as many software engineers. But then again, it's probably also going to create a lot of new jobs and different things like that on top of AI. So I would like to think that we're going to be good for a while, but I still don't know.
I think by far the best way to sort of future-proof yourself is to become an expert in AI also. Like at bare minimum, there will be a lot of software engineering jobs for a long time integrating AI into different companies.
Yeah.
Right. Like companies, if they want to start using AI as like a way to develop software, they're going to need engineers or people who are knowledgeable about AI to do that integration for them. The other thing also that I think just makes it one of those things that's just not all that worth like worrying about is just that in the event that GPT or whatever other AI is able to replace software engineers, and I'm sure at some point in the future we'll get there, that would also mean that it probably is able to replace pretty much every white collar desk job, right? Like, like there's not a whole lot of jobs that are sitting at a computer and typing that couldn't theoretically be done by AI. Yeah. And that is a huge, huge portion of the economy. So in the event that we got to a point where all of these jobs are being replaced, because I don't think software engineers will be the first ones of those jobs to be replaced. If anything, they'll be close to the last of those jobs because of their necessity in integrating the AI to replace the other jobs. But in the event that those jobs are all being replaced, there will have to be some sort of shift in society, whether it be universal basic income or something completely different. But there would be some societal shift because we can't just live in a society where unemployment's at 50%, because then all of these companies that have replaced all of their engineers and all of their employees with AI will have no customers because nobody will have any money to buy the products that they can't make anymore. And then we have no economy at all anymore. So like something would have to happen in that case. I think the more likely is just that new jobs come up that we don't know about, but there's also just like the potential of it being some other like societal shift in how money works. But
Yep, absolutely. Well, I really like that perspective, Connor, and I think here we will end it here. That wasn't too existential, so I'm okay with it. If people are like, hey, this guy knows his stuff, I want to learn more about him, see what he's got going on, where can they go to find you online?
Yeah, so just Connor Ardman on YouTube, TikTok if you like worse content, and frontendexpert.io if you want to check out the front-end development course we were talking about at the beginning.
Perfect. Well, thank you so much for coming on, Connor.
Yeah, thank you for having me.